Hello and welcome to the second part of Karl Pearson correlation. Now in this, the question is n is 7 and sigma x minus 1, which is given as 59, sigma y minus 2, which is given as 66, sigma x minus 3 the whole square, which is 337, and sigma y minus 4 the whole square is given as 434, and the last information which is given is sigma xy, which is 802. Now in this, out of all this information, we have to solve all the equation, and then we'll try to find out what is Karl Pearson correlation. So the formula which we can apply is n sigma xy minus sigma x into sigma y, which is divided by under root n sigma x square minus sigma x the whole square multiplied by second bracket n sigma y square minus sigma y the whole square. But the basic problem in this question is informations are there, but we need to find, except sigma xy, nothing is given, and n, which is 7, that is given. Rest of the things we need to solve the equation and we need to find the answer. So let us find one by one, where the first information is n minus 7 and the second is sigma x minus 1 equals to 59. So let us first use the first bracket. We open the first bracket and we'll find out the sigma x. So in this, sigma will be multiplied with x also and 1 also, and that is sigma x minus sigma 1 equals to 59. Now as we know, when there is only sigma, it is considered as n. So instead of sigma we put 7 and multiply with bracket which is 1, which is 59. So sigma x minus 7 equals to 59, and 7 will go to the other side of equation, and that comes to sigma x, which is 66. So this is how, by solving the first bracket, we derive sigma x. Now by opening the second bracket, which is sigma y minus 2, and which is given as 66. Now with the same way, we open the bracket, which is sigma will be multiplied with both the variable, which is y as well as 2, and sigma y will be as it is. Only sigma will be considered as n, which is 7 into 2, 14, and 14 will go to the other side of equation, which comes to 80. So 66 plus 14, we have also received the sigma y, which is 80. Next, we'll open the third bracket, and the third bracket which we have is sigma x minus 3 the whole square, and that answer is given as 337. Now we need to open the bracket, which is sigma the first number square, which is x square minus 6x plus 9, and that comes to 337. Now the sigma will be in multiplication with all these internal variable, which is sigma x square minus 6 sigma x plus sigma 9, and that comes to 337. Now in place of sigma x, we can put As we have just found sigma x is 66, so 6 into bracket 66, which is we just have found, and instead of sigma we'll multiply 7 into 9, which comes to 63. By solving the left hand side, sigma x square equals 2. So the left hand side we first solve, and the remaining number will put it on the other side, which is in addition to 337, and which comes to 670. So that is our sigma x square, which is 670. So we have received information like sigma x we have, sigma y also we have derived, sigma x square we have, sigma x y which is already been given. Now the only thing which is left, which we have to find to solve our Karl-Pearson correlation, is sigma y square by opening the last bracket, the information which is given. So the last information, the bracket which was given is sigma y minus 4 square equals to 434. Now the same rule applies, which is y square minus 8y plus 16, and that comes to 434. Now sigma will be in multiplication of sigma y square minus 8 sigma y and plus sigma 16. Sigma 16 equals to 434. Sigma y we have just calculated, which is 80. So 8 into 80 plus 16 into 7, which is 112. And by solving the left hand side, we will get sigma y square equals to, that is 434 minus 112 plus 640. So 80 into 8, which is minus on left hand side, will go to the other side and becomes plus, and 112, which is positive on left hand side, will go to other side, which will be minus. So sigma y square will be 962. That's the information. Now we have all the information to solve our Karl-Pearson correlation. Sigma xy, which has already been provided in the question itself, which is 802. So let's put up these figures into formula, where n is 7 and sigma xy, which is 802. In between there is minus sign, and sigma x, which we have just calculated, which was 66, and sigma y, which also we calculated as 80, divided by into first under root sign, which is n sigma x square. So n is 7, and sigma x square, let me put it the under root, this is first under root, multiply with the second under root, and while putting the numbers, sigma x square, which is 7 into 670, minus 66 the whole square. 7 into y square is 962, and minus 80 the whole square. So 802 into 7, which is 5614 minus 66 into 80, and that is 5280 under root into the first under root, which is 670 into 7, and then we'll minus 66 the whole square. That comes to that is 670 into 7 minus 66 into 66, which is 374. And similarly into the second under root also, this is 334, and in second under root also, which is 961 into 7 minus 6400 square, and that is also 334. Now on the numerator side, 5614 minus 5280, that comes to 334 again, and in denominator there are two under roots, and under both the under roots there is 334. So when you multiply 3 under root 334 into again under root 334, it will be only 334. So 334 divided by again 334, and that comes to 334 divided by 334. So R, that is Karl Pearson correlation, is 1, which is called positive 1. And if you want to interpret, it is perfect positive correlation between variable x and variable y, because R is positive 1. So thank you very much for the listening, and for further details you can visit my blogspot. Thank you so much.